Sid, who's delivering parts.
VFOs, variable frequency oscillators, you can do some really cool things with them. And obviously it's to do with the free tuning. But we're using this is connected to an SDR. I've got a mixer here, the AD831 Mixer, and we can do up conversion for the RTL SDR, which simply means that you don't need the up converters and you can run full quadrature sampling and get all the benefits from that. Now I knocked this up for less than 20 bucks, including the mixer. And the applications don't just stop with SDR, because you can control radios, transceivers, you can even use it as a signal generator. So I've made a couple of videos in the past regarding the SMA5351 clock generator, and I keep getting the same questions repeated. You know, how exactly do you make a VFO using the SMA5351? So that's what this video is about. We're going to go through what you need to make this, how to put it together, how to troubleshoot it, and then we'll look at the code, we'll look at the Arduino IDE and how to install it. So yeah, you don't really need any super electronic knowledge to do this, and I'm going to try and explain exactly, you know, how things are working as we go along. Now, of course, this is all based on the Arduino system. We're using an Arduino NANO, and we've got a display here, and we've got another display here, which is a 7-segment. This is an 8-digit 7-segment display. I've made this up on a bit of breadboard, and obviously we know we've got an Arduino. This is the clock generator board, the Si5351. We've got an OLED display. Now this is I2C. We'll talk about that in a second. We've got an IC on here, which is a CD4013, which is a CMOS device. Very cheap, but it's a D-type flip-flop. And that is, of course, for the Rotary Encoder. And over here, we've got some switches. So I've knocked this up. We've got quite a few little features on here. So obviously, if we tune it, we can see the display changes. Now what this is displaying is the frequency that we want to receive. So in the programming, what we've got is an IF offset, and it just simply means that if you connect it to a radio, you can set the IF offset. Now there's other things to do with IF offsets, which is, you know, some receivers are the mixers down convert. You know, you're reading the down converted image from the mixer, or other ones you're reading the up converted image from the mixer. Now in the code, again, we can simply manipulate that and tell it what we want it to do. So on these buttons here, we've got some bands, and as you can see at the top there, it says AM band, because that's what I call it. You can call these whatever you want, and you can arrange the bands as you like. So I've got these buttons here, so we hit the up button, we're going into the amateur radio bands. These are the ones I've programmed: 160 meters, 80 meters, 60 meters, 40, and so on, and it will keep going. Yeah, I've got it as high as the FM band, but you could put 2 meters on there, no problem. Obviously we're using this display as well. This is optional. You don't need this display. I just put it on there. I just quite like the look of it, and they look quite retro. Unfortunately, it doesn't come out very well on the video, but yeah, you can. There's an option to put that on, and we'll go through that as well. Also, yeah, we've got other buttons here. We've got tuning steps. So as we tune, as you see, we're tuning in 100 hertz steps. And if I change the tuning step, I can change it to 1 kilohertz, 1 hertz, or hertz, should I say, 10 hertz. Now, normally for amateur radio, you're tuning 10 hertz steps. And we've got encoder speed. So this is in fast. And the screen, it takes the screen a bit of time to update. But if you use a faster Arduino, it does seem to work a lot better. But again, we'll talk about that later. But we can change the speed. So if we can go to slow, as you can see, I have to turn it quite a lot. So it's good for fine tuning. And if I normally have it set on med. It depends where you are in the band. If you're looking at wideband signals like on the AM broadcast band, the high is perfect. But if you're doing some fine tuning, you want to may have it on slow. But if we adjust the tuning step, we can get to 1 hertz, and what the 1 hertz does, it actually adds another 0 on there. So if there's another feature with this as well. So if we take this down to AM band, that's the lowest frequency I've got programmed into it. Change the encoder speed to fast. Now if you wind this down, we're on 1 hertz. We'll change the tuning step to 100. There we go. So now it will come. It's coming down quite rapidly. Now when you get below 1 meg, it turns into kilohertz. So it's 997 kilohertz. So the actual marker has changed. And as we go back up, it'll jump back into megahertz, which, it's kind of a nice feature. Okay, so let's get into the build. Okay, so this is the schematic for the VFO. Now, I've knocked this up in Eagle. You can download it from the description. We'll go through it in some detail later in the video. But if we look in the bottom left-hand corner, we've got a parts list. Now, the first few items on this list are just generic parts. So we've got a couple of 10k resistors at 1/4 of a watt. We've got 3 47 microfarad electrolytic capacitors at 25 volts. Now, I've just used what I've had at hand. These are for decoupling because the displays can make a bit of line noise. So anything over 10 microfarads will work, and obviously our line voltage is 5 volts, so they need to be over 5 volts. We've also got this CD4013 BC CMOS IC, which is the D-type flip-flop. In fact, it's a dual package. It's got 2 D-type flip-flops in there. Again, we'll talk about that later. But you should be able to get this, almost anywhere. And we've got 4 momentary push-to-make switches, or push buttons. I'll change that to push buttons. So I'm not going to go into great detail on that. That's just all pretty self-intuitive. So let's start with the Arduino Nano 3 or clone. Okay, so this is the Arduino Nano. This is a genuine Arduino device made from the nice people at Arduino. However, it is a bit pricey. These are based around the Atmega 328P microcontroller, which is now microchip, I believe. But you can see this is $24.90. They're quite well made. The one I'm using is a clone, and this is where I got it from, AliExpress. Now there's a link in the description if you wanted to purchase one of these. We've got affiliate links, so we get a tiny little commission. I mean tiny, but it all goes towards the channel. Okay, so yeah, there's a couple of things you've got to look out for. So if you actually land on this page, let's just refresh that. It's showing you that there's, you're actually purchasing. It looks like you're purchasing, these nanos. But if you look here, this is highlighted, and this is a breakout board. That's what you actually purchase. Now, I fell into the trap when I purchased it. I thought that's what I was buying, but it wasn't. So you have to click on these little images for exactly what you want, and you can see the price changes. It's available in a number of configurations. you can get it like this, which you get a lead. You'll need a programming lead. Now this is using a mini USB. There are clone versions of this that use Type C's and various other USBs, but this is the one I've purchased, and it works perfectly well. It's using a mini USB, so make sure you've got a compatible cable for that. But here you have to solder the pins in yourself, so these are little pin headers, and if you're going to solder them in, what I did, and it's a good little trick, is to put the pin headers into the breadboard at the correct spacing, then fit this board on top and then solder the pins. And the reason for that is it just keeps the pins, the header pins, at perfect right angles to the NANO board. Otherwise, if you solder them in, by freehand, they can be on a slight angle, and then when you want to put it into the breadboard, they don't fit properly. So it's a good little trick there. So they're available with them soldered in for a little extra cost, so they're already pre-soldered, and we've got one there. So there's a couple of variations, but this is where I got it from, AliExpress. This is the seller. Yeah, works perfectly well. I haven't had any problems with it. Just one thing to bear in mind and look out for: some of these clones don't come with an Arduino bootloader. What it is a bit of software, it's a bit of firmware in there, so it means that the Arduino IDE will work correctly with the device. Now this one does. If you see here, driver at Mega 328p, main IC bootload has been written to the board, so it's just saying yes, it's had the bootloader burnt into it. And if we go down here, it tells you that you have to set the old bootloader in the configuration on the IDE. We'll go through that when we get to that stage, but yeah, these have got the bootloader on them and they work. Okay, so if you're new to the channel and you like this content, please consider subscribing or hitting the like button, as it really helps the channel. We're trying to grow the channel, so thank you in advance for your support. And of course, you're going to need a Si5351 Breakout board. This is from Adafruit. I haven't tried one of these. I've actually got one in order. It didn't get here in time to make the video. But I imagine this is pretty good. Adafruit makes some really cool stuff. They are absolutely brilliant and great concepts. And especially if you're learning and you're a maker or you enjoy playing around with breakout boards, Adafruit really have come up with some great concepts. But being the cheapskate that I am, I've actually got this from AliExpress. Now this is the one that I've been using. There are quite a number of variations on this. There's a few people in China making them. There's not a lot to the circuit, to be honest. The most critical part on there is obviously the Si5351, but it's it's the crystal. They use a 25 meg crystal, and crystals are quite unstable, and the way it works, you just got to be careful. They're very sensitive to temperature. We'll cover all this as we go on, but this is the one I've bought. I got it from AliExpress. As you see, there's a link in the description. Now the only thing with this is that you have to wait a bit of time to get the parts delivered. So here in the UK, we're looking at 12 to 16 days to get delivered. But this is the one I'm using. It seems to work fine. It's quite suitable for tuning amateur and general purpose radios. The OLED display that I'm using, these are 128 by 64 pixels, and they're based on the SSD1306 IC. That's the driver IC that's built in on the display board. And there's a few variations of this. We can get them obviously in blue, you can get them in white, but you also get different sizes. So this is 1.3 inch, so it's slightly bigger than the standard 0.96. Most of them seem to be 0.96, and yeah, they work. They're I2C compatible. So if we have a look on here, we've got ground, VDD, SCK, which is really SCL, and SDA. Now these two make up the I2C. It's the serial bus. Now the thing to pay attention, you know, all these screens will work on this page, but is the ground and VDD or VCC. It's just the positive, so if it's negative, that's positive. The orientation of these can swap between boards. So if we have a look at this one, yeah, VCC then ground, and we look at this one, it goes ground then VDD, same thing on this one. So yeah, these all work. Obviously, I haven't designed the board to work with this sort of board. I think these are, yeah, I think they are still 128 by 64, but it's different orientation. So you want this type of board. These work fine. Got them. They're cheap, you know, and they work really well. Oh yeah, and you can get the split colours. Some of them have, you know, this is yellow blue. So, you know, it means it's got a yellow band along the top there. And that's basically the ones that I'm using. But, yeah, there's quite a selection there. They're not very expensive. They're nice and bright too, so, you know, they do work quite well. So, in order to tune the radio, you're going to need a rotary encoder. These are quadrature encoders, again, from AliExpress. Now, there's quite a bit to encoders. What I will say is that don't be tempted to use something like this. These are mechanical encoders, and yeah, they just won't work properly. You need something like this. Now these all produce a nice square wave. They're very straightforward to connect up. These are designed for CNC machines like shaft encoders. And I've sort of been on the hunt to try and find good value sort of, you know, rotary encoders, you know, because a lot of these things can get really expensive. And there's obviously an outfit in China manufacturing these, and they're actually pretty well made. You've actually got in here, there's actually a bearing, so it's really free turning. The shaft's 6mm, so it'll take most knobs. And I find you want a nice, large, weighty sort of knob stroke dial, you know, dial knob to go on here, because they, you know, you can spin them up. But these work incredibly well. Now I'm using the, you can select them here, but I'm using the 100p, well, it's PPR, and it just basically means 100. It keeps swapping, I don't know why. It's 100 pulses per revolution. Now you can get them in various types. You know, if you get the higher pulses, so like 400 pulses per revolution, I imagine that the Arduino will struggle to count them. Most amateur radio, I repair a lot of radio equipment, and most amateur radio equipment uses 100 PPR rotary encoders. But the only thing, obviously, these are not designed to be panel mounted as such. You know, so if you've got a panel mount it, what I would suggest that you would sort of cut a hole to accommodate this sort of upstand section here, and then probably, yeah, you could actually drill and put some screws in there. I think they come with some screws in the box. If I was going to do it, what I'd do, I'd just score this up and I'd just araldite it to the back of an enclosure. You know, it would be, I'm sure it would be solid. If we come down, it says here, look, the diameter of them is 38mm, so they're quite a size. But there are sellers on AliExpress that sell a lot more narrow units, I think down to about 20-something mil diameter. So if you were going to fit it into an existing radio, they probably fit. I haven't tested them. But if you come here, yeah, make sure you select the 100 PPR. They've got quite a long lead on them too. They're really straightforward to connect up, and they've got a voltage range that work from 5 to 24 volts. Now you've got to be careful with this 5 volts, and we'll talk about that later as well, because I think I've run into a few problems with the Arduino, but I'll show you how you get around that. And of course the outputs on these are just simple transistors, so if you did decide to feed it with 24 volts, these have got a 5 volt regulator built inside them, and all it's doing is just switching the base of 2 NPN transistors, so it won't affect anything to do with the circuitry you're connecting it to, because there's no connection to the input voltage. So let's look at the schematic. So we're going to put this thing together. I think we'll start with the Arduino. So this section here, this is, I can get it into screen. Okay, so this is the Arduino Nano. Now, what we're doing with this circuit, we're actually using the power that comes via the USB. So the USB cable connects from here to a PC or laptop, and that allows us to program and communicate with the Arduino. It's just a standard, it's nothing special. I said programming lead before. I mean, it's just a standard USB cable. There's no electronics in it. It's just but you just got to make sure you get the right one for the board you've got. The 5 volts comes in here, and we're supplying, we've got 5 volts here, and what we're doing is we're just using that to power all the other devices. Now we've got a number of things on here. These sections here, if you look down here, this is D2, D3, D4. This means that they're digital input outputs. So they can be inputs, they can be output. It depends how we program the Arduino. And on this side we've got A0, A1, A2, A3. This is simply the analog input outputs. So again, we can decide whether we want these pins to be inputs or outputs in the program. And if the other connection we've got is here, which is ground. So yeah, which goes to the ground pin. These are all silk screened onto the actual Arduino Nano, so it's really straightforward to work out what goes where. Now on pins A4 and A5, this is our I2C. Now I2C is just an industry standard serial bus. I think it was developed by Philips back in the 1980s for televisions, but it's become very popular. So there's 2 components to I2C. We've got the SDA and SCL. It's a 2-wire system. It needs a ground as well, but it's for our purposes a 2-wire system because everything else is grounded. So what we do? Well, we've got these other devices on here. Let's just run through them quickly. We've got this 8-digit 7-segment display. Very straightforward. This is optional. If you want to put it on, I will go through this at the end of the video if people are interested in connecting one of these things up. It's very straightforward. But as with all these devices on here, we've got VCC, which is our 5 volts, and we've got ground. We've got a breakout board for the SMA 5351, and again we've got V in, which is basically the VCC, which is 5 volts, and we've got a ground. So we just want to make sure we power all these modules, they all get power. So here, VCC, ground. This is the OLED display, which is again very straightforward, and it's the same for the optical, the rotary encoder. So VCC, ground, and I've actually put on here, the colors of the Y is red for positive, black for negative. It's pretty straightforward stuff. And if we get down to here, we've got our flip-flop, and again we've got 5 volts, and where's the ground pin? VSS, which is pin 7, which is going to ground. And there's a number of pins going down to ground on here. We'll get back to that in a second. So once we've got our devices powered, we've got these capacitors here. This is the decoupling capacitors, and you just put them as close to these devices as you can on the breadboard. And if you're making it up, you know, it's exactly the same if you're making it up on a prototyping board. You know, try and keep them as close as you can. Okay, so our I2C, now this is the serial communication, and basically what it is, the Arduino is along this serial bus is telling the other devices what to do. Now there's two devices hanging off this, which is the clock generator, which we simply send up a piece of information up there to tell it what frequency we want it to be on. There's a few other parameters that we can send up there. And there's the OLED display. We simply tell it what we want it to display, and all the information comes up via here. So these are actually, I've just done this for ease. So SDA is connected to it. They're all common. So it says SDA, they're all common together. So these are literally daisy chained along these two devices from pins 4 and 5 on the Arduino. We've got some push buttons down here. This is band down, band up, tuning step and speed. Now, as we said, these are normally open. One side of the push buttons all go to ground, and the other side of the push buttons go up to pins D9, D8, D7 and D6. So let's look at the rotary encoder and how the Arduino interprets the information that comes from it. So these are optical rotary encoders, which simply means inside the unit itself there's a disc that's perforated, and there'll be a light source and a photoelectric cell. Now there'll be two, and they're offset at critical distances, and I'll explain why in a second. But what it does, it creates square waves. So on A and B we will get a square wave. Now in order to get this we need to use pull-up resistors, and as you can see I've got this 10k here and another 10k here, which are tied to the A and B line, which ultimately go up to the 5-volt rail. So when these transistors get switched on, this line will go low, and I can illustrate that here. I've just done a little diagram. Now this is obviously what's inside. Obviously at the top here, these two 10k resistors are our external pull-up resistors. So on the base of this transistor, if that goes high and switches the transistor on, at this point it will pull the voltage low, and you know, if we're sending a square wave here, we'll get a square wave out here. It will just be inverse to the output will be inverse to what's coming in on the base. So I found this diagram on the internet, which sorry about the focus, but I think it's a good illustration. Now there's a lot to quadrature. There's quite a bit to it, and there's a lot of people can explain it a lot better than I can. But basically, this illustrates what's happening. So if we turn the rotary encoder, say clockwise, and we can see we've got our A and our B square waves. A is leading B. So this is switching on before B is switching on. And if we turn it counterclockwise, B is leading A. Now, with this, we can figure out which direction the rotary encoder is turning. So if we get back to the drawing, we have got, let's have a look here, we've got this flip-flop. Now the Arduino itself is quite capable of reading quadraturing signals, and it can figure out which direction. But when we're using high speed, because these are quite high speed rotary encoders, so the faster you turn it, remember it's 100 pulses per revolution, the speed, the frequency will get to the point where the Arduino will struggle with it. So this is while using a D-type flip-flop. So if we look here, we've got one side, which is, I've got B, which comes in and goes in on pin 3 of our D-type flip-flop, and then the other side, which I've called clock, comes along and then goes into the Arduino on pin D2. Now there's an interrupt on there. We've got an interrupt set up. All that simply means is, as part of the, because remember it's a microcontroller and it goes through a routine. It can only be at one place at one time in its routine. But what it does when we set an interrupt, it means the microcontroller will pay attention to what's going on that pin. Okay, and the other side, which I'm using the A on this, goes down to the data 1 input. Now there's data 2, and if you see there's set 1, set 2, reset 1, reset 2. So in reality we only need the set 1 taken down to ground, reset 1 taken down to ground. But I've taken the other ones down because there's 2 devices in this package. So simply these are high impedance devices, and I've simply tied the other bits down to ground because I don't want it taking off, going into self-oscillation, which CMOS devices are very good at, by the way. So yeah, it's important they're all tied down. But yeah, so what's happening? So as the data comes in, so we've got a clock and a data, this will flip one way or another depending on which square wave is leading. And ultimately what will happen on Q, on the output, this in one direction, this will be high at 5 volts, and if you turn it the other direction, it will simply be low. And if we get over to our Arduino, our direction comes in here, and it's a lot easier for this, to do it this way. So the Arduino will see if pin D3 is high, let's say it'll start counting upwards, and if it's low, it'll start counting downwards from the information that's coming in on the clock. So it's just simply counting the square waves, and depending on what DIR is, if DIR is high, it will start counting upwards, and if it's low, it'll start counting downwards. Okay, so I'm going to end this video here. In the next video, we'll go through the breadboard layout, how to troubleshoot it so we know it's working properly. We'll look at the Arduino IDE, how to install it, how to configure the libraries, and we'll run through the code and upload the code to our VFO.